Hello everyone, today I am Rishabh Bhardwaj, Assistant Professor from Mechanical Department taking the lecture of Automobile Engineering. In this lecture, today we will discuss about the topic that is exhaust gas recirculation in 4-stroke engine. Simultaneously, we will cover one more topic that is positive crankcase ventilation that are generally in short known as PCV. Let's start with the introduction. The main problem of facing by today world is environmental pollution. Because of this, the vehicular traffic is major contributor in this. The exhaust gases from the vehicle including the carbon monoxide, carbon dioxide, hydrocarbons and oxides of nitrogen and some other residuals. Now of these nitro oxides or nitric oxides is particularly very harmful for our environment. These are one of the chief constituents of smog which have an adverse effect on ecological system. They are also contributing to the formation of acid rain in our environment. And nitric acids or oxides of nitrogen also cause breathing illness in human beings. How does the nitrogen oxide form? These are the very common factor or very crucial component of the exhaust gas by which we are getting harmful toxic substance in our environment. The factor that causes from the diesel engine to run more efficiently than the gasoline engine also cause them to run at a higher temperature. This may lead to the creation of nitrogen oxides, and the fuel in any engine is burned with extra air or some of the oxygen is used to burn the fuel. When the peak temperature are high enough for the long period of time, the nitrogen and oxygen in the air contributes to form nitrogen oxides. These are normally collectively referred to the nitrogen oxides. Let's discuss that how can the nitrogen oxide can be reduced. In order to reduce the nitrogen oxides, our engine should run at lower temperature than the normal temperature. And reduced cylinder temperature can be achieved in the three ways. First, by enriching the air fuel mixture. Second, lowering the compression ratio and the retarding ignition timing. And third, reducing the amount of oxygen in the cylinder. Next we have a exhaust gas recirculation. The exhaust gas recirculation is an effective method to reduce the nitrogen oxides emission from the engine. It works by circulating a quantity of exhaust gases back to the engine cylinder. Intermixing the recirculation gases with incoming air reduces the amount of available oxygen to the combustion and lower the peak of temperature of combustion. Recirculation is usually achieved by piping a route from the exhaust manifold to the intake manifold. A control valve within the circular regulates the 3 times the gas flow. In the systematic diagram you can see the installation of the EGR. How does it work and at what position it has been placed. Initially the air fuel ratio is entered in the engine to get ignite. Then The engine will work on the fuel and exhaust it to the silencer. Through this the exhaust through the exhaust pipe or the exhaust manifold, and a hose take back that exhaust gases to the EGR cooler, where the recirculation exhaust gas fraction will enter and reduce the temperature through the water cooling. That water will enter and water will get out, by which the heat will get dissipated, and cooled EGR, that is exhaust gas recirculation, will get again back to the air fuel ratio, by which it will enter again to the engine. By the help of this, we are able to use the unburned fuel, and even the oxygen, the nitrogen oxides also be reduced by this. Next we have a basic component of the EGR. There are three basic parts of EGR. First is EGR valve, second is EGR cooler, third is EGR transfer pipe. These three basic components will help in the total complete component of the EGR. In this figure you can see the typical 4-stroke diesel engine with basic parts. In the first, when the EGR is required, the engine electronic control open the EGR valve, and second position, the exhaust gas flow through the pipe of EGR cooler. In the first figure, the exhaust gas or EGR valve will open to the turbocharger, by which we are able to reuse this exhaust gas again to the intake valve or through the injection. Okay. In second figure you can see that EGR transfer hose pipe hot to the from the exhaust valve. This is the position at which it has been installed. The EGR operating condition, there are the three operating condition in EGR flow. That first is light, then high, and no EGR. Three components that you can see in the figure, that is light, low, and heavy. And EGR ratio, at the very light load, the EGR will not get any high pressure, or at the heavy load, or when we have a high RPM, the EGR will get flowed into the engine. At the light position, when we are moving it in first or second gear, no EGR flow will be takes place. When we started the load ratio or we increase the speed, the low EGR will flow, and at the high speed we get the high operation values for that. The purpose of EGR system is to precisely regulate the flow under different operating condition. By integrating the fuel and the spark control with the EGR, metering system and engine performance and the fuel economy can be enhanced. For this, an ECM, that is electronic control machine, is used to regulate the EGR flow. When the EGR is required, the ECM opens the EGR valve. As you can see in this figure, that the ECM is capable to neutralizing the negative aspect of EGR by programming additional spark advanced and decrease fuel injection during the period of EGR flow. In this example, you can see that intake taken by the cylinder and exhaust given by the cylinder. The exhaust gases and enter to the turbo. Now the EGR valve rotate and EGR cooler will make them cool and allow them to enter in the system. And the exhaust gases in the turbocharger will also come again to the engine cylinder again. In the experimental result, the relationship between EGR and the oxides of nitrogen. In this you can see that we have on the different loads, the value of nitrogen oxide due to the EGR will get decreases. And in the figure of relationship between oxygen concentration and nitrogen oxygen due to the load or at the high load, the EGR percentage is much higher as compared to the other one. Then we have a hydrocarbon and nitrogen oxide concentration at the function of EGR level. In this, the EGR percentage is increases and the oxide nitrogen initially will get decreased. Initially the rate is very high, but due to the EGR the value become lower at the percentage of EGR increases. The dotted line in this shows the nitrogen oxides that are decreasing by when we using the EGR percentage values. The relation of PM accumulate rate and oxygen and nitrogen oxide emission with EGR. Next, what we have the technical issues over there. First, we have a combustion contamination. Exhaust gas from any combustion process may have certain contaminants. It may lead to serious combustion, degradation and instability and shorter component life. Second, we have a control system stability. The control system for modern engines have developed over the 2 decades to maintain the emission control at varying load, speeds and the fuel conditions. Adding EGR into the combustion process introduce further complexity that must be carefully integrated into entire engine control system. Approach for successful operation over a wide range of conditions. Third, we have a material and the durability. EGR system may decrease long-term life of the component affected, including the EGR cooler and control valve, the piston and the cylinder heads, and the exhaust manifold and the sensors. Continuous duty application may cause material breakdown, shorter component life, and even unexpected catastrophic engine failure. Next, we have the future of EGR. The current proposal required a functional check of EGR system that detects a malfunction when the system has reached its control limit, such that it cannot achieve the target EGR flow. And it is required a functional check of the EGR cooling system for the proper cooling. As we can conclude that Using the EGR technique in engine, the emissions are very much controlled due to less amount of nitrogen oxides entering the atmosphere. The exhaust gas recirculation is a very simple method. It has proven to be very useful and is being modified further to attain better standards. This method is very reliable in terms of fuel consumption. EGR is the most effective method for reducing the nitrous oxide emission from the engine exhaust. Next we have a crankcase ventilation system, or we can say the positive crankcase ventilation. In this, it is a way for gases to escape in a controlled manner from the crankcase of an external combustion engine. The internal combustion inevitably involve a small but continual amount of blow-by. It occurs when the sum of the gases from the combustion leak past and the piston rings to end up inside the crankcase. In the positive crankcase ventilation, it had invented during the time of World War II. And a different type of crankcase ventilation be invented to allow the tank engine operate. The normal draft tube ventilator allow water to enter the crankcase and destroy the engine. PCV reduces blow-off emission from the engine, and about 20% of hydrocarbons emission reduced by a vehicle. The higher the mileage on engine and the greater the wear on the piston and cylinder, the greater the blow-by into the crankcase. Let's see how the positive crank ventilation works. A hose connected to the top of PCV valve to the vacuum port on the throttle body, carburetor or intake manifold. This allows the vapors to siphon directly into engine with respect to gumming up throttle body or carburetor. PCV has same effect on air fuel mixture as a vacuum leak. Now you can see in this figure we have positive crank ventilation valve by which we are able to transfer the flow. Intake manifold allow the air intake and throttle to combine fuel the air and the combine the air fuel ratio, and it reduces the heat of crankshaft. You can see in this figure that we have the component that will be used in the positive crankshaft ventilation, that is air cleaner, air intake hose, throttle body, air intake plank, ventilation hose, intake manifold, injector, and the main important is positive crankcase ventilation valve, by which all the heat will be get transferred to the ventilation hose which will enter to the intake plenum, and the intake hose will take the air or heat to the engine also. For today it's come to an end, and in the next lecture we will discuss about more about the automobiles. This is come to an end that we are taking the knowledge today about the recirculation of the exhaust gases by the through the help of positive crankcase ventilation and simultaneously with the exhaust gas recirculation device. Thank you for watching this video and stay tuned for the next. Thank you.